This learning path is intended to help learners to start their preparation to take the developing solutions for Microsoft Azure AZ-204 certification exam. Microsoft Azure developers are responsible for taking part in each phase of the cloud development process. They define solution requirements and design, develop, and maintain those same solutions. Azure developers are also responsible for performance tuning, monitoring for solutions they create, and the content in this path can help you kickstart your exam preparations. So please write down your comments, questions, and suggestions in the comment box. This channel really needs your support. So in order to make these videos visible, please like, share, and subscribe if you haven't done so. To make this content free and available, I put around 100 hours of preparation. So I would really appreciate your thumbs up, and I will not talk about it again in this video. Hi, welcome to Tech of the Day. I'm your host Nitesh Sharma on this channel, and I will guide you through this journey of AZ-204 developing solutions for Microsoft Azure Developer implement IaaS solutions. This is the second part, which contains two topics in itself: provisioning and configuring Azure Virtual Machines and creating and running containers in Azure. This video will be covering the first part, which is provisioning and configuring Azure Virtual Machines. The second part will be covered in next video. If you want to watch the whole series, the whole AZ-204 13 hours course, you can uh, go and look into my channel, and you will find the 13 hours course which covers everything. And if you want to learn topic by topic, then this series is the best, and you can continue on this video. So as I said, this whole course or this part covers implement IaaS solutions, provision virtual machines, configure, validate, and deploy ARM templates. So, and then this is the first part which this video covers, and second will be create container images for solutions, publish an image to Azure Container Registry, run containers by using Azure Container Instances. Let's continue. Get started with a high-level overview of what a virtual machine is composed of. Let's look at virtual machine components. Azure virtual machines are deployed into resource groups and are contained in Azure regions. When deciding what region to put a virtual machine in, you will likely want to put a VM physically close to the applications or users that need to use the service deployed on that virtual machine. When building a virtual machine, you must choose a VM size of the VM. You pick from a selection of pre-configured virtual machine size based on the number of CPU cores, the amount of RAM, and also varying disk performance capabilities. What size you pick depend on the workload being deployed on that virtual machine. And the good news is size of the VM can be easily upgraded or downgraded after a virtual machine is deployed. The next core element of virtual machine deployment is networking. This networking connectivity for your virtual machine to rest of your environment, and if needed the internet. You will have an internal IP address for the internal communications on your Azure virtual machine virtual network or VNet, and if required a public IP address can be allocated that's reachable from the internet. And we will talk a little bit more about the security and remote access in few minutes. The next component in a virtual machine is virtual machine images, and that are the base image used to deploy into our virtual machine, most often operating systems like Windows or Linux. In this course we are going to focus on deploying Windows and Linux virtual machines built from Azure Marketplace images. Azure Market, there are many different virtual machines image available in the Azure Marketplace based on many different operating systems. There are varying editions, images, and pre-configured applications, and also even network virtual appliances. The final component of the virtual machine is storage. Each VM created will have a block device called Azure Virtual Disk or VHD. Each virtual machine will have at least one virtual disk or hosting the base operating system. For hosting the base operating system, you need that virtual machine, the virtual disk. And if needed, additional virtual disks can be added to support application data. How much disk capacity is required and its performance capabilities really depends on the amount of data that needs to be stored and your workload's performance profile. So now that we know what a virtual machine is composed of, let's look how to create a virtual machine. So just remember these 5 components for a virtual machine creation, and let's continue. When creating a virtual machine, you have the full suite of Azure tools to use, and first one that we are going to look at today is the Azure portal. This is web portal that you are used to use when working with Azure resources, and it can be used to create virtual machines. Now, if you want to build a responsible process to create virtual machines, you are going to want to do that in code. And core ways to create virtual machines using code in Azure are Azure CLI, PowerShell, and Azure, which with the Azure module and the Azure ARM templates. Because as I said, if you do anything from portal, that is good, well and good to get started. But if you want to keep it in the consistency of your resources, then you have to choose a solution, either use Azure CLI, PowerShell, or ARM template or Bicep, because then you can have the version control. You can store those scripts or code into your GitHub repository, and then you can keep the version control of it. And you can also use the continuous deployment and delivery. So now there are some additional ways to create virtual machines in Azure using things like APIs, but those are out of scope of this course as well. So we are going to focus only on Azure portal, Azure CLI, Azure PowerShell with Azure module and Azure template. So let's continue. So now, okay, I'm here in my Azure portal, and as you can see, I'm just at the start page, and I will just say create a resource, and I will look for the virtual machine, and this is the first one option. I will just say virtual machine, and then it just asks me which resource group I want to use. So I will use the existing resource virtual machine name, and you see virtual machines in Azure have two distinct names: virtual machine name used as the Azure resource identifier and guest host name. When you create a VM in the portal, the same name is used for both virtual machine name and host name. The virtual machine name cannot be changed after the VM is created. You can change the host name when you log into the virtual machine. So keep it in mind, very important factor. Virtual machine host name and the virtual machine name. So first time I will create um, AZ-204 and VM, and that is all right. Okay, this is going to create virtual machine, so the name of the virtual machine and the host name will stay the same. And then I chose, by default it gave me North Europe availability zones and zone 1 standard. A lot of things are here to understand. Region you already know. Availability options. Azure offers a range of options for maintaining availability and resilience of your application. Architect your solution to use replicated VMs in availability zones or availability set to protect your apps and data from data centers. So if you have done already Azure 900, you already are aware about these things. What is availability zone, what is availability set, what is resiliency. You should know these things. If you don't know, I would simply suggest to go through these terms, because I don't want to cover them here, because these should be covered in the Azure 900, which is basic. But in case if you haven't appeared in the Azure 900, then I would suggest you to go through them on internet or Microsoft Learn. You will find a lot of solutions there. But I will go with the default options, and here you see security type, and it offers a lot of security. um, trust Trusted launch virtual machines, confidential virtual machines, and this is the standard virtual machine. Images, very interesting one. You see here a lot of images are there. You see Ubuntu, Red Hat, Linux, Windows Server, Windows. I would go with the 19 Windows Server, and you see, and then it asks me which size I want to go with, and by default it selected the standard one, but I can see all the sizes here, and I can choose cheapest one or expensive, whatever I want according to my requirements. So how many virtual CPUs you need, how many RAM, how many data disks, and how many max IO apps you need, and according to your requirements you can make the decision. But also if only the cost is your requirement, and then I will just simply select the cheapest one. So for now it's just selected, let's select this one, and this is just 9.42 month per month. Now it asks me to create a username for my application, AZ-204 user. I just created a nice user, and it is just suggesting me the password. A password is pre-written for my previous virtual machine, but I will say test is a 204 user. Okay, it is not fulfilling one condition, which is one uppercase character and one number and one special character. I have to write down again. It is good to know that your password should have one of three of the following. So it has the number and everything. So let's say age at 204. Then it's a user, and still the password is not good because it should be 12 and 123 characters. User 1. No, not still. So user pack of the day. Very long password, and I'm not sure if I'm going to remember this, but doesn't matter. Age at 204 user pack of the day. Oh, it matches. Okay, so I have the username and password. For later on I need to configure the inbound and outbound rules. Public inbound ports, none, allow selected ports, this. This is very important if you want to use your virtual machine for RDP, but you can also say SSH, HTTPS, and HTTP, which then it gives you some warnings. But I can just disable HTTP, SSH, and HTTPS. I will just say RDP, and then this will allow all IP addresses using your access to your virtual machine, and then that's it. And then if you would like to save on licensing because you might want to use some hybrid benefits, you can select this option, and then I can confirm, and then it will cost you very less. But I will not select this, and I will not select this option. And next is disk, so I don't want to save. And next is disk, and this is again by default it gives you premium SSD, but you can just go down and you can go standard HDD because the premium SSD is expensive. Again, that cost you a lot. Um, and I can continue, create and attach a new disk if you want, and attach an existing disk if you want. Then I want for the networking part, I want to create a VNet virtual network, and with subnet ID, with public IP this and NIC blah blah blah, everything is there, and then I can continue. So this is basically setting up my virtual network part, and then I can go for the management. um, Everything, how do you want to log in, auto shutdown, you see enable auto shutdown between some time, uh, after some specific time, is after a specific time. If you want to backup, how do you want to backup the virtual machine guest OS, and patching. So enable host patch up, so guest update, the OS you are going to use beneath the virtual machine. So basically you are having some automation in here, and then I go forward and I create the virtual machine, and that's it. I can add the tags. Next I can review and create. So for now it is just validating the virtual machine and my script, and then it will say if the script is validated, then it will create. Basically this is not a script, this is simply an ARM template. So till now we have created an ARM template via uh, Azure portal basically, and that's really interesting. And then I can just click create, because it was already validated, so I should not have generally any problem until unless I do not have things like creation rights, or I do not have the subscription which supports it, or maybe some policies are there. So runtime validations are not done. When it does the validation, it only validates your template. So if I just go here, you see it's a template, and now a deployment was created for that template, and you see a lot of resources are being created. You see IP, public IP address, NSG, VNet, and Zone, and then the real virtual machine is being created. And you see it has created an ARM template. We will talk about it later on during this course, because yeah, as I shown you for how to create app service using ARM template, I will also show you how to create virtual machine using ARM template. Let's wait for this. This will take some time because yeah, it is heavy work. We are kind of creating a machine, right? So yeah, it is some heavy work. Let's continue to the course, and I hope it is clear for you. As a developer, you are used to write code to build applications. Well, in Azure, you will have the ability to create virtual machines and infrastructure using code. And deploying infrastructure like virtual machines with code provides your organization a lot of value. Let's walk through some of the key reasons why you would reasons for deploying virtual machines using code. First, deploying virtual machine with code adds consistency to your deployments. As I have said previously as well, deploying via code always increase consistency. Virtual machine creation, so that you can create 1, 10, or 100 virtual machines the same way every time. No difference. And like any other code, you can have other that code and take the deployment code and check into source control. Next time any production system should be implemented using automation, primarily because you can build repeatable source control processes that can be used to deploy your environment. And last but not least, with your deployments in code, you can take that code to construct similar down level environments such as dev test. And this can add consistency to your to development and testing cycles. Since you are able to replicate your production configurations easily and consistency in non-production scenarios, your app is genius. So now that I have convinced you that you should be implementing your Azure development deployments in code, let's look at the tools that we are going to focus on in this course to help you do just that and Those tools are Azure CLI, Azure PowerShell with AZ module and ARM templates. Whether you are creating virtual machines using Azure CLI or Azure PowerShell with the AZ module, the high-level process to create a virtual machine in code consists of the same steps. First, you create a resource group in region if you already don't have one. Then next you execute the command needed to create the virtual machine. In PowerShell, that's new AZ-VM, and in Azure CLI, that's AZ-VM create, and then specify appropriate parameters for those commands to create the virtual machine, and we will get into the code for the upcoming sessions. Now, if you need remote access to the virtual machines over the internet, you need to ensure the appropriate remote access ports are open on the network. Security group securing your virtual machine and its interfaces. The ports that needs to be open depend on the remote access method for your virtual machines operating systems. For Windows, that's TCP port 3389, and for RDP, and for Linux, TCP port 22 for SSH. In addition to the remote access ports, you can also specify if your application ports such as 80 for HTTP, 443 for HTTPS, and so on. As I have already shown you while I was creating the virtual machine on Azure portal, you could select HTTP, HTTPS, SSH, or RDP. You can also add rules to the network security group directly to control access to this virtual machine based on the port's IP address, and doing so is recommended, but it's of course out of the scope for this course. Lastly, to access this virtual machine from outside of Azure, you will want to retrieve the public IP address from the virtual machine itself. Once you have the public IP address, you can connect to the virtual machine remotely and begin working on that VM. We will look closely at the techniques for doing this in both PowerShell, Azure CLI in the upcoming demo. Now this course is certification focused. If you want to deep dive in the programmatic deployment of virtual machine inside of Azure, be sure to check my other videos how to create virtual machines using different options. So let's walk through the code needed to create a virtual machine with the Azure CLI. The first thing needed when creating a virtual machine in the code is to create a resource group. We can create a resource group with the Azure CLI command AZ group create. We give that resource group a name. We give that resource group a name, and then we choose the location that we want to create the resource group in. I have already shown you how to do that because we did that for the app creating app service. You can of course deploy a virtual machine into an already existing resource group, and then the next step is creating virtual machine, and then you can do that with AZ-VM create, and then you pass in the resource group name that you want to create the virtual machine in, and then you give the virtual machine a name. So so what I'm doing here is AZ-VM create in the resource group tag of the day RG with the name this one. So this is the name of the virtual machine, and then the image Windows 2019 data center, admin name, admin username, demo admin password 123 star blah blah blah. And then there is another way. If you have AZ-VM create Azure resource group this, name tag of the day Linux, image Ubuntu, admin user this, auto authentication type SSH because it is Linux, and then SSH key value is this one. So you see, for two different types of image, we have two different types of things here, the parameters. So simply you can do this. I would not do this demo myself because I have already shown you how to do that. This is pretty forward, pretty straightforward, pretty easy. I will put these commands uh, in the no, I will not put it in the description, but I will put or I would suggest you to go to this resource actually, because there you will have a lot of commands there. You can easily get the one which is useful for you. Why I'm not doing this as demo? Because then you will not be able to learn. I want you to do it yourself so that you can understand what I'm talking about. And let's continue. Enabling remote access. So now once that virtual machine is finished deploying, we can move on to the next step, which is to open up the RDP for access, remote access into this virtual machine. We can do that with the code here on line, um, which says AZ-VM open port in this resource group, name of the resource group, name of the virtual machine, and then it says this port. So it is simply saying create a rule to open the virtual machine uh, on this virtual machine, and then say open this resource group, which is with the parameter 3389. So let's go ahead and run that code to open up that port for remote access into the virtual machine from IP address. Once the X process is finished, um, I would really suggest you to do that, and I hope you're following till now with me. I want you to do that with me, and I want you to execute. Once it is finished, um, and then you can open up that port for remote access. Once it is finished, then you can access. I would definitely want you to access RDP for accessing the virtual machine. Then here we have the command azvm list IP addresses, which lists the IP addresses, and we specify the resource group and the resource group name and the name of the VM, and we say list the IP addresses. It will list all the IP addresses. What public IP addresses of this virtual machine is. So my public IP address for this virtual machine will be xyz, let's say x.y.z.a because it is for things. Yours will be most likely different. In addition to the public IP address, the virtual machine is also having private IP address. In my case, it will be, let's say, blah 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 172.16.1.4, and that will be used for applications and services either inside of the Azure or that have some sort of private connectivity into our VNet. Now for this demonstration, I'm not going to log into this Windows virtual machine with a RDP on public IP address. We saw that how to do that in the previous demo, because that is time consuming and this video will become too long. But I want you to do that because this is not difficult. You just go to the portal and select connect part, and then you select how do you want to connect, and it will download one RDP file. You just click on the file, you enter the username, you enter the password, and you are in the VM. Let's continue. So as I said, I want you to do that. I will not be doing this myself, but I want you to creating VM with Azure CLI, enable remote access using Azure CLI. As we have already all these things in place, I want you to use that and mm, do that yourself. Again, then once you have done the Azure CLI, I want you to continue doing that with PowerShell as well if you are interested, because you might have the same thing in exam. In exam, they might ask you with the Azure CLI or Azure PowerShell. So for exam perspective, you have to do that for both. CLI and PowerShell. For your interest perspective, you can ignore it. So, so to understand this, we have a PowerShell script which says username is this, password is this, and Windows credential, which is creating new Windows credential using this. So we have created Windows credentials using username and password. This is simply a PowerShell command. If you don't know, please look at new object. It is simply creating new object using this PS credential. Then we continue. What we are doing here is simple. We are creating a new Azure VM. If we already have this source resource group, if we don't have this, we will create the resource group as well in the location of the VM. Here we are simply saying name of the virtual machine is this, image is this. We should know exact name of the image because we have the predefined images, so we have to choose the name of the image from the existing images only. And then for the credential part, you see I'm using Windows credential which I created here. This is simply a variable. And then open ports 3389. I'm already telling the VM the command to execute to include this in the script itself to open the port 3389 for RDP connection at already, right? So I already have the RDP connection here. And the previous one, we opened it ourselves. And while I was creating the VM using portal, I added this as well. So generally you have this option already, so you don't have to open and run the previous command we ran previously, but sometimes you might. And then if you just want to get the public IP address of this virtual machine, then you have to specify the resource group name and the name of the virtual machine, and then you need to filter the select object IP address. Simple, right? Pretty straightforward. So I would like to urge you to go to Azure portal, select the cloud shell, and run these commands using PowerShell. I hope you know this already, but I have explained this in the video as well previously, that you can just execute these commands. If you want to learn more, you can go to Azure Virtual Machines Linux create quick PowerShell. You can go to this URL, pause the video, and just search for quick create PowerShell. Uh, quickly create for virtual machines, and then it will take you to this, or you can manually type it in. I will also put a link. There is this guy Sean Bart who has added useful links to his website, and I think I will put his link because I feel that is interesting, so I will add him there as well. Okay, let's continue. So I guess I have explained you the PowerShell command. Now I want you to do that in the demo. Um, so I hope you will pause this video and do a PowerShell creating virtual machine using PowerShell. I have already explained it. For your sake, I would show it again. So pause the video. I will not highlight with the yellow color and just do it. Let's continue. And then I hope you will do that. So this is simply a demo which I'm skipping. I'm not doing demo using PowerShell and enabling remote access using PowerShell, which I could do, but I want you to do that as well. because yeah, that's simply the thing we want to do here. And I also want you to see later on, verify, get the public IP address, and also check what is your public IP address and what is your private IP address, because private IP address is used for internal communication, public IP address is used for external communication over the internet. Let's continue. Let's move moving along in our journey of learning how to deploy virtual machines in code, Azure. Let's talk about ARM templates. An ARM template is JSON formatted file that is configuration document that defines what resources you want to deploy in Azure with their configurations. You can create any resource with ARM template. In this course, we are going to focus on virtual machines, but I have already talked about what is ARM template, its structure and everything. If you want to learn more about ARM templates, I will be creating a specific video about infrastructure as code, and I will suggest you to watch that. But for AZ-204 perspective, you can continue doing this course. ARM templates are building block for deployment automation. Using ARM templates, you can just deploy your application, parameterize configuration elements for your resource defined in ARM template. You can use parameters for commonly changed configuration elements such as virtual machine names, virtual machine storage account name, and more. You can use that same ARM template repeatedly to deploy the environment defined in the template, but using different parameters to customize each environment as deployment time. So the examples of having one set of parameters for production, another for QA, and another for dev, still using the same ARM template but with different parameters, providing consistency to your deployments. From a process standpoint, you create an ARM template, and then an ARM template is submitted to Azure Resource Manager for deployment using the tools that we focus on in this module, and the Azure portal, Azure CLI, and Azure PowerShell. Once the ARM template is deployed, it affects the changes defined inside the ARM template. In Azure, changes such as creating the resource, edit existing resources or their properties, or even deleting resource. So basically, every when I saw you the demo in Azure portal, you saw in the end it created a template, and then it created a deployment, and that deployment was actually creating different resources for that virtual machine. So like it was creating NSG settings, it was creating NIC, it was creating VNet, and then in the end it was creating virtual machine. So let's continue. Um, Simply have already explained this, what is ARM template, but let's talk about it again. ARM template format, if you know it, you can skip this part. Yeah, first we have some header information schema in the location of the JSON schema file that describes the template language. Then the content version of the is the version of the template which is defined by you, the user. Control of your template. Next is API profile, which allows you to for the versioning of the resources and the defined in the template. Then next we have parameters, which is used to provide values during the deployment of that deployment, so the same template can be reused for multiple deployments. This is where you will define your deployment specific configuration parameters, and this is very useful when you want to be able to use the same template and over again, but changing out the parameters for specific deployments, as we said, for test prod and staging. So things like resource group, regions, resource names, and network configuration are common parameters. Variable define values that are used in your template and are often constructed from the parameter values. User defined functions allow you to create customized functions that simplify your templates and help enable reuse of template. A common use for function is generating resource name based on the environment that it is being deployed to. So with the functions, you can just create deployment specific resource names. And then you have resources. A common sorry, the based uh, resource is where you will specify the things that you want to deploy. So virtual machines, storage accounts, networking elements, and so on. Outputs are typically return values from the resources being deployed. This allows you to inspect and use the output in systems that are driving the deployment. So things like scripts and other deployments tool. Now, in addition to user defined functions, there are also collection of predefined ARM template functions available to help you manage your deployments. So for example, there is function to look up the Azure resource ID for resources given its string name. For more operations, more things like that, I would highly urge you to go to this website from Microsoft Learn and check for Azure Resource Manager and then templates and then template functions. It is simple and straightforward. It looks difficult, but as I would say, it is really easy. Just go through this. So, time for a demo. Let's go to Azure portal. So while I was creating a VM using Azure portal, I was having this thing here. I was here and it created actually a deployment. It created a deployment simply for below resources like Azure VM, IP, NSG, VNet, and this was networking. NSG, yes, and this is VM, and then shutdown compute VM resource also because we configured automation to shut it down every um, at 7 p.m. So it simply created a schedule for shutting down the VM. Anyway, so what it did, it actually created the ARM template. Now we have this ARM template, and in this ARM template, you see inputs. Inputs are the inputs we put from the while I was creating the VM using Azure portal. Then you have some outputs, which is AZ user and the template. Inside the template, you have parameters. It is like this. So you have parameters, variables, and resources. It created 6 resources in total. You see here network interface, NSG, virtual network, public IP address, virtual machine, and it also created a schedule for to shut down the virtual machine. So in simple, it has created a an ARM template, and now what I want to do is I can simply go ahead and download this ARM template, and I can show you here. So I downloaded this ARM template, which is basically the same thing which we just saw, and it has output. So we just saw this part, right? So I can download this virtual machine and I can add it to my source control, and I can also um, send the values for these parameters. So let's say depending on my environment, depending on my requirements, I can change the values. Like I can change the location if I want to deploy different another virtual machine. I can have a different virtual network related configuration here, so which will be different for different environments, and then I can have different username, password, mechanism for login, patch mode for these things as well. I can have different options. So basically, what I want to say is, as I said in the beginning, that if you automate your deployment, which is like CI/CD, when you use it in your deployments, you are simply taking the overhead of doing everything manual, first of all, but you are also increasing the consistency. Your production environment will be the same as your dev environment or the vice versa. So when you face any problem in production environment, you will be able to solve the problem quickly and easily because you know both environments are same, so it will be easy to reproduce the same error or problem in your dev environment. Second thing is, You are not dependent on human, right? So next day, if your developer leaves the team, you are gone, right? Because the information is also going to leave from your team, because that specific developer did some manual changes in the Azure portal, and then okay, you are no more able to do that because he just changed something in the Azure portal. So basically, your knowledge is still staying if you keep your code, if you do the deployment using the code. So I hope it's clear. And to deploy the same thing after the changes, I can just simply deploy like here. I can just say deploy, and it will create a deployment. So it is a custom deployment, and it took the values already provided from the ARM template, but I can also modify them. You see, I can modify these values myself and change them. Basically, it is simply creating a deployment. It is not creating a specific um, resource. It is creating a deployment, and that deployment itself will contain 6 resources, you see. So it's a custom template, and it will create 6 resources. If you want to see them in the visualizer, you will see it has 6 resources and how they are related. Oops, it is so fast. So basically, you are creating a Azure virtual machine, and for that you are creating NIC, network interface, and for that NIC you are creating NSG, virtual network, and then also you are creating public IP address. Simple, right? So this is basically it. So if you go back to template, and you can also deploy the template, if you don't want to do it like this, you can also, so this was one of the ways. You could also do it from a custom deployment. You could just go to custom deployment like this, custom deploy a custom template. And here you have many options. So build your own template in the editor, which will give you option to upload it. And you can also do custom template, common templates which are already there. You can use pre-existing ARM template, which is for Linux virtual machine, Windows, creating web app, SQL, whatever. So but the basic idea is you can build your own, and you can load a file which you already have, let's say in your Visual Studio Code, and then you can upload that file and then save it, and then go back to custom deployment, and then continue from there. So basically you can deploy any ARM template like this. I
Right,
hope it's clear.
that's a
Let's
wrap.
continue. Please write down your comments, questions, and suggestions in the comment box, and good luck with your exam. I hope you learned something, and because I tried to explain everything in my own way, maybe I wasn't clear enough, and maybe you have some feedback for me. So I would really appreciate your feedback. I put a lot of hard work in it, but maybe still it is not enough. I put more than 100 hours in preparing this course because it's really long, and uh, it covers a lot of topics. Still I might not have done a lot of demos maybe, but I would be creating a separate video for that, which will cover labs and some some other exam topics. So thank you for watching, and enjoy tech of the day, enjoy um, this course, and good luck for your exam. Hope it helped you a little bit, at least some degree. Thank you. Have a nice day or evening, whatever is suitable to you. Thank you. Bye. Have a nice day.